will focus on KNN snipers. So this algorithm is different from logistic regression, and LD is the same, as useful for classification purpose, but this one we don't have any complication. It's called non-parametric algorithm. That means we don't have a complex equation to run. You just have to the classification is based on the closest distance for each point. So imagine you have any points in your data set, and you need to classify this point. It depends on the distance. Who was close to this point, it will be classified based on the distance. So the distance between points is typically calculated using either Euclidean distance, and distance between each point will be calculated x2 minus x1 square plus y2 minus y square. So the KNN principle is machine learning algorithm that classify data point based on the proximity to other point. So imagine we have this x value and we need to classify this point. So in KNN it will classify this point based on the adjacent point. Which point have, for example, we have the blue point here, we have the orange one. Which one is closest and have the majority? So because in this circle we have two blue points, so this x will be classified as a blue circle because the blue in here have the majority and very close to this point. The idea is to look at the k closest neighbors. So all these called k neighbors, and to given data point and decided is to classify based on the majority class of these neighbors. So here's the majority in here, class on this neighbor. So which one is the close in this cycle, and we'll divide in based on this one. So x will be classified as a blue circle because a blue in here is have the majority, the close to them. So depending on the number of neighbors, if you have number of neighbors equal to 1, so the model will be looking for each individual's point and will be more complicated and it will be have more noise. But if your number of noise, for example, is very big, and then the boundary will be very smooth, and he can classify points based on the we don't have too much noise and the boundary will be so smooth. So if k equal to 1, the algorithm look for the closest point to the test point and classify the test point based on the classes of the nearest neighbors. If k equal to 100, the algorithm will looks at the 100 closest point and classify the test point based on the majority. So in here, if you have k equal to 1, it will give him which one is close to this one. He will take classified based on the closest neighbor. But if you have the k equal to 100, it will take 100 neighbors and classify the point that you need to classify based on the majority. K equal to 1, the classifier become very sensitive to noise. In the data, if the nearest neighbors is a noisy or outlier point, it might incorrectly classify the test point. But if k equal to 100, the classifier become more generalized, smooth, and robust to noise because it looks at more points. Okay, so here it will be a lot more points, and here will be look for individuals, and we have more noisy. Here we have a smooth data. This is what the KNN. So if you work with the KNN, if you have different individuals independent variables, for example, we have height in centimeter and we have weight in kilogram. So if you have too many different units, so you need to normalize your data. That means you keep all your data is between 0 and 1. So all data, they have to normalize it and keep between 0 and 1, and then you can work with KNN. So I'm just going to apply what we learned today in the R Studio. First, you need to unpack class. This is for function for classification for KNN, and you need K tools. This is for splitting our data into test and train. First, I'm gonna set my seed. and then sublet. Sublet in here and equal to assign to false. So firstly you have to set your seed, otherwise you will have different data whenever you run your training and test model. So firstly you have to set your seed, because we talk about that, because you will have different data every time you run your data. Okay, so you have to set your seed, and then we split our data so into 8%. So 80% this is for train data, and 20% it will be for the test data. So this is true assigned for the train data, and the false is assigned for test data. So this is, it will be train data is 80% and test data is 20%. And set so seed, it will keep your data. If you have, you can see that train data 386 observation, it will keep the same value you select because you set your seed. If you don't set your seed, you will have different value every time you done your model. I'm gonna go train x equal to train set, and I'm gonna execute my minus 16 first, max 16. Okay, I need my test, so it's train test x, my train test set, and this one same, minus 16. I need also my y to be my train y. I'm gonna explain to you that. I'm gonna keep it here, train y equal to, this is train set $, this is equal to salt, and my test y, it will be equal to test dot set $, this is salt. So what I'm doing here, I keep my, just tell the model this is my x data and include all the training set except the 16, where 16 column is for salt. Okay, this is column 16 is for my salt data. So this is my x data and this is my y data. This is my just test. I need to test the model after I run the KNN and test the model, we see if it's working properly or not. So this is my train x and train y. This is y is salt, and this is my training set just for salt. So this is, I'm just telling him this is my y equal to salt, and this is my x equal all the variables except the salt. So okay, I'm gonna keep it here now. If I need to change, I will change it from here. I'm gonna scale our data now. Train x minus scaled underscore scaled equal to scale train x. I need for a train x, and train, this is for test x underscore scaled, this is scale equal to test x. So because you know that we have to scale our data, so to scale our data, I'm just gonna scale my independent variables only for x. We know to scale, I'm not scaling my y because the y is already 0, 1. So I need only to scale my x data and my to become just, and you can check that for the test train set. Okay, so you can check that. Now if you scale your data, you will have the value between 0 and 1, 0 and 1, 0 and 1. This is what we are doing. So because as we talk about KNN is only you have to scale your individual particles between 0 and keep them between 0 and 1, otherwise you will have very big values not representing. And k equal to 3 in here, I will tell you now what does that mean. Let me run our model now. KNN dot predict. I'm gonna predict that equal to, we have to use the KNN function, and I'm gonna use my train, okay, the scaled, and I use my test x, okay, and I need my, this is a train, my train y, and this is k equal to k. If I run my model now, object train y, okay, I need to run that, okay, and so my model now, I use the KNN function. This is, I need to predict my classes in the train set, and using my data and my train data, and based on the my train y, the target, based on the target variables y, and k equal to k equal to k in here, because if I have to change the k, I only have to change it from here. If I change it to 1 to 100, only click on this k, this one will change automatically. You can keep it k equal to 1 or 2 in here, but I keep it outside because if I need to change, I will change it from here. So now let's gonna run our confusion matrix, and we see if we run our confusion matrix, so we have to build the table. In the table we have to bring KNN, the predicted one, with our is test, with our test y. We check the test y and scene data to check our model, and if so I get like 29 plus 30. This is like is the is corrected value that covered by this KNN prediction, while we have like 30 plus 29, so this is 90, 59% is correctly covered by this equation. If I need to change, if you see, we can change this one to 3, and any time you change your value, we will have different values. So now 28 plus 30, 39, so we have like 66 value is covered, is correctly covered by this equation. And if we check the difference between the three models that we ran to now, so you have to decide based on the data. So this one give us the accuracy 69, with KNN with equal to 3 give us the accuracy is 55%, while LDA was give us 66%. So you can run your three models and decide which one is best fitting for your model. So thank you for your watching. Please subscribe and leave me comment, and see you in the next video. We'll cover the decision tree, and see you in the next video. Thank you for watching.